Adding, subtracting, and multiplying radical expressions. Radicals that have the same index and the same radicand are called like radicals. What that means is the cube root of x and the cube root of x are like radicals. If they are not like radicals, it would look like the cube root of x and the square root of x, or the cube root of x, the cube root of x squared. Both the root and what's under the radical have to be exactly the same to be considered like radicals. When we add or subtract like radicals, we say we combine like radicals. In this example, we want to simplify the following. A, 4 square root of x plus 2 square root of x. Because I have x to the first and they're both square roots, I have like radicals. I can add the numbers in front. 4 plus 2 is 6, so this equals 6 square root of x. For part B, I have 3 square root 5a plus 2 square root 3b minus 6 square root 3b plus 7 square root 5a. The square root of 5a would be like radicals. I can add 3 and 7, so that equals 10 square root of 5a. The square root of 3b would also be like radicals. 2 minus 6 is negative 4, so I can write that as negative 4 square root 3b. The square root of 5a and the square root of 3b are not like radicals, so my answer is 10 square root of 5a minus 4 square root of 3b. I can also write this answer as negative 4 square root of 3b plus 10 square root of 5a. For the following examples, we want to simplify. Part A, I have 6 cube root of x minus 1 minus 3 cube root of x minus 1 minus 2 square root of x minus 1. Because of the index, only 2 of my roots are like radicals, the cube root of x minus 1. So I can find 6 minus 3, which is 3 cube root of x minus 1, and then I bring over minus 2 square root of x minus 1. My answer is simplified as much as possible. I cannot combine the cube root of x minus 1 and the square root of x minus 1. For part B, I have the square root of 18x to the 5th plus 2x square root 50x to the 3rd. My indexes are the same, but my radicands are different. However, I can simplify them. 18 I can rewrite as 9 times 2. X to the 5th I can rewrite as x to the 4th and x. So 18x to the 5th simplifies to 3x squared times the square root of 2x. Bringing over my 2x, now I want to look at the square root of 50x to the 3rd to see if that could be simplified. I can rewrite 50 as 25 times 2, and x to the 3rd I can rewrite as x squared times x. So that gives me 2x, times the square root of 25 is 5, the square root of x squared is x, and I bring down my square root of 2x. Rewriting 3x squared times the square root of 2x plus 2 times 5 is 10, and x times x is x squared, and I bring down my square root of 2x. Because I have x squared times the square root of 2x for both terms, I can add 3 and 10, and my simplified answer is 13x squared times the square root of 2x. Multiplying radical expressions. Another version of the power property for radicals. If the nth root of x is defined, then the nth root of x to the nth power equals x. In words, the nth power of the nth root of a number is that number. For these examples, I want to simplify. Part A, I have 6 square root 5x times 4 square root 10. For multiplying, as long as my index is the same, I can multiply the roots underneath. So I can multiply 6 times 4, which gives me 24, and 5x times 10, which gives me the square root of 50x. 50 has a perfect square, 25. So I have 24 square root of 25 times the square root of 2x. Bring over my 24. The square root of 25 is 5 times the square root of 2x. And 24 times 5 is 120. So my final answer is 120 square root 2x. Part B, I have in one parentheses 4 square root x plus 5, in the other parentheses 2 square root of x minus 7. To work this one, I need to use FOIL method, or I need to distribute the first parenthesis through the second parenthesis. Either way, I want to begin with 4 square root of x times 2 square root of x, which will give me 8 square root of x squared. Then I want to multiply 4 square root of x times negative 7. 4 times 7 is 28, so I have minus 28 square root of x. Then I want to multiply 5 times 2 square root of x. 5 times 2 is 10, so I have plus 10 square root of x. And then I multiply 5 times negative 7, which gives me negative 35. The square root of x squared is going to be x. So I have 8x minus 28 square root of x plus 10 square root of x are like terms. Negative 28 plus 10 is a negative 18, then square root of x minus 35. So my final answer is 8x minus 18 square root of x minus 35. For these examples, I want to simplify. For part A, I have in one parenthesis 3 square root of a minus the square root of b, in the other parenthesis 3 square root of a plus the square root of b. Again, we're going to use FOIL method, so I multiply 3 square root of a times the 3 square root of a, which gives me 9 square root of a squared. Then 3 square root of a times the square root of b, I have plus 3 square root of a times b. Then I multiply negative square root of b times 3 square root of a, so I have negative 3 square root of a times b. Then I multiply negative square root of b times a positive square root of b, which gives me negative square root of b squared. 9 square root of a squared simplifies to 9a. 3 square root of ab minus 3 square root of ab is 0, minus the square root of b squared is b. So my final answer is 9a minus b. For part B, I have in parentheses the square root of x minus the square root of 3 squared. I have the square root of x minus the square root of 3 times the square root of x minus the square root of 3. Using FOIL, I have the square root of x times the square root of x, which is the square root of x squared, the square root of x times the negative square root of 3, which is the negative square root of 3 times x, negative square root of 3 times the square root of x, which is the negative square root of 3x, and then the negative square root of 3 times the negative square root of 3, which is a positive square root of 9. Square root of x squared is x. Negative square root of 3x minus the square root of 3x is negative 2 square root of 3x, plus the square root of 9 is 3. Final answer, x minus 2 square root of 3x plus 3. Adding, subtracting, and multiplying radical expressions. To combine like radicals, we have to have the same index and the same radicand, which means I can add the cube root of x to the cube root of x, but not the square root of x to the cube root of x. When multiplying, I can multiply anything that has the same radicand. So I can multiply the square root of a times the square root of b, which would give me the square root of a times b.